So what happens when we don't have a right triangle? We can use the law of sines. Now, the law of sines is derived from our trig functions, but it allows us to find the missing sides and angles of any triangle. And when the law of sines doesn't work, we have the law of cosines, which I'll go over later. So in this example, we're asked to find both x and y. All we're really doing here is setting up ratios of a side to an angle. And that angle is opposite that particular side. And so what I always do when I'm trying to find or solve these problems is I look at the angles that I know or that I want to find, but really I start with the stuff I know and I try to find an angle side pair that is known, and I see that here. And so I'm going to go ahead and do it in the same format as here. It doesn't actually matter as long as you're consistent, but I'm going to put the 17 side on top, and then on the bottom I'll put the sine of the angle, 62 degrees. And so I'm just going to stay consistent and put all the sides on top and the angles on the bottom. I look here and I can find it, but I don't have the angle opposite y at this point. So I'm going to look at the other thing that I already know, which is the angle 73 degrees, and its opposite side is x, which I'm also looking for. So the side goes on top and the sine of the angle goes on the bottom, and then you just solve using our algebra. Here's the trick though. You don't use your calculator. Don't pick it up until you've isolated x. So I'm going to go ahead and cross multiply here. So it's going to be x times the sine of 62 degrees is equal to 17 times the sine of 73 degrees. Trying to find the value of x, so I'm going to go ahead and divide by sine of 62 degrees here. Again, that creates a 1. So I'm left with 1x on the left side, but then I need to balance my equation. And we find that sine is equal to exactly 17 times 70, or the sine of 73 degrees divided by the sine of 62 degrees. We can, of course, plug that into our calculator and figure out an approximate value. And we get that x is approximately equal to 18.41. Again, we have our exact answer, and we also have the the approximate answer. I'll put the approximate answer up here, signifying that it's approximate with those squiggly lines. Great, so now I know x. I recommend pausing the video and seeing if you can find y on your own. Now, I will point out once again, we're probably not going to want to use this approximate answer to find y. It'd be much better to use this ratio again, since we know that it's exact. You could, of course, use this part right here, because that's exact, but that would obviously be kind of a pain. So pause the video for a moment, see if you can solve it on your own, and then I'll go ahead and solve it in a moment. If I want to find this angle here, theta, if I want to find theta, well, I can just add all three of these up, and they have to equal 180 degrees. So theta plus 62 degrees plus 73 degrees has to equal 180 degrees. And you can go through and solve that on your own. And we get that theta has to equal 45 degrees. And so now I can replace that variable I just made up with 45 degrees, and I can set up my ratio. So I know that the sides are going on top, and the side here is y. And on the bottom, I put sine of its angle, 45 degrees. And then we go through all the same steps. We cross multiply 17 times the sine of 45 degrees and set that equal to the other cross multiple, which is y times sine of 62 degrees. Go ahead and divide by sine of 62 degrees to isolate y, creating a 1 there on the right side. And we find out that y is in fact equal to 17 times sine of 45 degrees over the sine of 62 degrees. And there is my exact solution. I'm going to approximate it. We see that y is approximately equal to 13.61. So I'll put that up in my diagram here. And then we can do our little check here. The smallest angle is 45 degrees. And if I look here, 13.61, that is the smallest side. So that's good. The next smallest angle is 62 degrees. And if I look opposite that, that's 17. That's the medium side. and the biggest angle is opposite the biggest side. So at least there's no contradictions there. The values all seem fairly reasonable, and so I can feel pretty confident that my solutions are correct.